one of the things I want to say, so the title is XR Technology, What Can It Do For You? And I couldn't help thinking when I was reviewing my presentation, I was reminded of a famous quote by U.S. President John F. Kennedy in the 1960s who said, "Ask not what your country can do for you, but what you can do for your country." So maybe with regard to XR technology, I'll say the same thing maybe. Ask not what the technology can do for you, but what you as artists can do for this technology to help shape it, because that's actually quite important. So imagine we have a virtual reality headset, you put it over your eyes, and inside you see a different world here. Each one of your eyes is presented with some images. They could be synthetic graphical images. They could be some images that are captured by a camera that could bring you into the real world, either recorded or live, or you could, or this could be completely virtual, as in a kind of game world. Oh, I see. I'm pointing all the time here, which is not. Okay, now. I hope. No. How do I make it? Let me think. Sorry. Yeah.
Sorry.
No, it's a problem. This might be distracting for folks.
Oh, it's not doing anymore.
Okay, thank you very much. And so this technology works by presenting different images to your eyes as you turn your head, so that it fools your brain, first fooling your eyes and then ultimately your brain into thinking that you're in some other place. So a little bit about the technology and to help divide the different kinds of headsets or wearable displays that we have. There's what's called 3DOF tracking systems, which only look at the head orientation. So you can imagine like your collarbone is anchored down and you just look around and it will track the motions of your head at that level. If you start maybe sitting in a chair and moving around like this, you might make yourself a little dizzy because it cannot track those kinds of motions if it's a 3DOF tracking system. These are the cheapest, and the technology is based mainly on the inertial measurement units that are inside of your smartphones for doing this. That kind of technology. More expensive, a bit more elaborate systems, although they're getting cheaper all the time, involve 6DOF tracking, where we add X, Y, Z motion around in the space to it. So it gives you the ability to walk around perhaps, and the design choice for different products is how big is the tracking area. Maybe you sit in a chair and that's all you do. Maybe you walk around an entire large area like this, perhaps with the chairs removed, and you can do that as well. There's solutions at different levels. The accuracy varies wildly as well. This is one nice way to kind of look at kind of the way the ecosystem is for VR, and I'll get more to AR in a bit and kind of unify things together. But you can go at the low end for about 200 euros. You have Oculus Go, which is 3DOF, and it's what's called an all-in-one headset. So the same pieces that are in your smartphone, let's say, got kind of scrambled around and customized into a virtual reality device that's connected by Wi-Fi. And then some lenses, and there's a small controller. And then Oculus Rift is coming the other way, which is PC-based, a bit more expensive, and has a 6DOF tracking. And then Oculus Quest, which is supposed to come out in a few months, is a kind of hybrid. It's very much like the all-in-one headset, a little more powerful than Oculus Go, less powerful than Oculus Rift. Does 6DOF tracking, but does it using cameras in an unstructured environment, which makes it less accurate, we expect, but more portable and flexible, because these first two headsets here are completely wireless. So everything's moving wireless in VR, AR, in this whole space, which is very good for the University of Oulu, considering its massive 6G project that's just starting out. I list a bunch of headsets here. This is 2016. That was kind of the peak of when everyone said the VR revolution is happening. Now it's back down again a little bit and turning more into like a calm, sort of sane levels of enthusiasm. So I just put some different devices here. Cardboard eventually. If you've only tried virtual reality with something like Google Cardboard, then you haven't really tried it, I would say. So you have to upgrade your experience. Maybe Google Daydream is significantly better. This is to put your smartphone into the device. There's many of those around. That's a kind of upgrade over Cardboard, but then the all-in-ones have come along. HTC Vive, there's an HTC Vive Pro now, which is a significant enhancement over this. And also we can go off into the AR space, Microsoft HoloLens. There's Sony PSVR, which is in many ways the most successful of the VR headsets because it's leveraged directly off of its gaming console ecosystem. I think I've already said these kind of things, just kind of talking about things. HTC Vive is probably one of the most expensive of the consumer products. The Vive Pro is a little more expensive than that, and those are US dollar prices before finished taxes and things, so maybe you can scale, you know how to scale those probably. I didn't try to make adjustments. Another thing that's happening very rapidly is the development of panoramic camera technology. And I just want to say that those go hand in hand with the development of these kinds of VR, AR devices and such. And so 4K, 8K, you know, how far are you going to go? But I just want to point out that you can capture a full viewing sphere and then send that to a virtual reality headset, and then when a person is wearing the headset, they can look around and see whatever part they like, which gives the user or viewer a lot more control. That may be problematic for typical cinematographers, because you cannot control where the user looks, and we'll see a little bit of that as I go along. So a lot of the problems right now are image stitching. How are the images glued together if it's made from multiple cameras? You can see there are multiple cameras on these kind of devices. If you only have 2 cameras, it's a lot easier. Every camera will get different lighting levels, try to do its own adjustments, camera synchronization, image distortions that have to be corrected at the boundary. A lot of issues there. Some solutions, I think this particular one will do it all yourself, but if you get up to if you're a professional editor of movies, you probably would like to do it yourself in-house, and then you need a lot more tools and techniques to try to customize it and perfect it. So there's a lot of issues there. There's also a big challenge right now, or question about whether or not there should be 3D depth information as well, and have that projected to the eyes. Sometimes it's more trouble than it's worth because it has a lot of flaws in it, or it may even give people headaches. And I'll explain some of that hopefully as I come in a little later. We've been waiting for years for the killer app in this space. Even the phrase killer app seems to suggest something like a smartphone ecosystem, right? It sounds like we're talking about apps on a smartphone. But this is a very different kind of platform, so I'm not even sure if that's the right phrase. I want to talk about a bunch of apps, just a kind of random selection of things that have caught my attention, let's say, over the years, just to give you an idea. And then we'll try to talk a little more about art in the next part of the talk, and then I'll talk more about kind of engineering technology and how it comes together with the art. So what kind of things? As I said, you can do panoramas. That's one of the early things. I'm not sure if it was mentioned, but I was an early founder of Oculus, and in fact did my early work from Oulu, which I'll even mention a bit about later. It's kind of a surprise to some people. And one of the very first, most exciting applications we found when we released the Oculus Rift headset was that people started viewing panoramas in them, and it just grew very quickly. Google Street View was extremely popular at that time. And you can have, of course, panoramic live concerts, sporting events, all sorts of things like that. In an effort to quickly leverage content, there was a young man in Korea who developed a virtual movie theater. And then all of a sudden you could stream things. That's why you have Netflix and all kinds of things like that inside of VR experiences now. You can just take all the content that's already there and project it into a virtual movie theater or whatever kind of place you want. You can even have social interaction or other kinds of experiences. Maybe you can have movie night with your friends all around Finland together in one place, and then you can throw paper airplanes inside of the theater or do whatever you want without getting forcibly removed, right? So you can have some fun like that. One very important area that I've seen a lot of is digital heritage. I can think of 2 important cases, and then I'll have sort of a third case after that that sort of fits on. But the 2 important cases, maybe the site exists right now, but visitation is limited, or might be hard to preserve the site. So it may be very difficult to access, or maybe just the people going there are destroying, having too many people going there are destroying the actual location. I'll give an example of that in a bit. Another one is the ruins exist, but do people want to go and look at the ruins, or would they like to see how it looked in its early times? And I like to think of this Sir Arthur Evans controversy on the Knossos site. That's the original, believed to be the original labyrinth for the Minotaurs in Greek mythology. This is on Crete. I was there, and I couldn't help feeling bad about this. This is an attempt to reconstruct what it might have looked like exactly on the site itself. So wouldn't it be nice to have some augmented or mixed reality technology, for example, where you can put on some glasses and see what it might have looked like without actually destroying the ruins or changing the ruins in some way. And you could go completely in a virtual environment, just make a complete model of this, and not even have to visit the site. So there are 2 different kinds of things you can do. You can either merge your realities at the site itself, or go into a completely virtual environment. So that's an example of the second case there. The first case, I got a bit involved with a couple of years ago, where there's the Mogao Caves in Dunhuang in western China. And this is extremely important to the Chinese people. It's the place where Buddhism was brought from the South Indian subcontinent over into China, and there are many small rooms that are caves, more like rooms that are carved into the side of cliffs in the very dry desert region. Because it's so dry there, they're very well preserved. But when a bunch of people keep going to these caves, which are hard to get to, but people still go, and just the moisture from their bodies is damaging the walls. So, so the Dunhuang Academy has done a lot of work to scan things. This is an example of what these caves look like. And there's hundreds of them, if not more than that, maybe thousands. I remember a lot of caves. And so the Dunhuang Academy worked on building 3D scanning models, 3D scanned models. They've done a lot of this, and so you can go and visit this in a virtual world. So I had a number of students working on this at the University of Illinois when I was there in a joint project on that. There's also an Oulu story, which is maybe it exists today, the site, the heritage site, but it might not exist tomorrow. So at the University of Oulu, there's the well-known zoological museum, which was there for many years. And then in order to make room for mergers and acquisitions and things of that nature at the university, it was decided that, well, this museum, which had to be destroyed, could at least be preserved in virtual reality. So at the Center for Ubiquitous Computing at the university, the researchers there have carefully scanned all the animals that were in this. These are actual animals that no longer are living, and they scanned their bodies and brought them into the virtual world. So now children and grown-ups too can visit the virtual museum of animals, and you can do kind of interesting teleportation to the virtual wild where these animals exist, provide other information, all kinds of possibilities involving fantasy. So this is what it looks like in the virtual world. Things tend to look much cleaner and newer in the virtual world. I don't know how to make them look fully real world. And you can have augmented information there, right? You can press some buttons and sort of virtual buttons, and you can hear the sounds of the animals. You can get information about them. It's quite nice. So you can make it better than maybe well, I wouldn't say it's better, but you can make it better in certain ways than the original one. But of course, the original one will be lost. So this is a very nice thing that you can do. Other examples. People have said that this technology is very good for empathy, and this should appeal to artists, I think. You have a chance to give someone a first-person perspective. One of the things that I found very moving, this was a 360 video made by Chris Milk for the United Nations a few years ago, and it involved following a young girl named Sidra around through Syrian refugee camps, and you can see what her daily life was like. So I found that really fascinating. And it did feel a lot more powerful to me than a simple film on a screen. Getting a little bit weirder, one of the things that got my attention was that you could swap bodies with people. So this lab in Spain, this was mainly supported by perceptual psychologists, neuroscientists, and they wanted to give an experience where you have a virtual reality headset on with some cameras, so that you can wear the headset. You have two people there, and when they wear the headset, you look down and you see the other person's body. So you can get the idea of what it's like to be in someone else's body. You can see they're even moving their hands. They're going, "That's me." So very interesting, right? So you can be somebody else. So the embodiment that you can get, right? It's a different kind of embodiment. That's a powerful concept that you can give someone in an artistic context, right? You are someone else now. How does that feel, right? The artist should be able to run wild with this. Very standard engineering kinds of things, or architecture kinds of things you can do. Virtual prototyping. I know that's very big around in Finland. There's many companies here. I know Kubikasa and Oulu here, for example, has done interesting work. So of building 3D models for real estate purposes or for architectural design, city planning as well. Of course, there's a lot of interest in these kinds of things. I'm not even sure which one's the real one or the virtual one there. These things are getting pretty good. Can anyone tell? I think maybe the bottom one is virtual. Okay. I worked for 20 years in robotics as a researcher, and so I can't help getting fascinated with connecting these technologies to robots as well, to give people a sense of mobility beyond what they're ordinarily capable of. Maybe someone's elderly or has an illness like ALS, they cannot go out and move about. They could have a surrogate body through a robot and be able to experience the world. So I think that's a fascinating use for this technology, combined with panoramic cameras. Of course, I can't possibly stand here without talking about bringing video games into virtual reality. One warning I will give, though, is that it's very easy to take something that's, say, developed in Unity, some game engine, bring it directly into virtual reality, and then the problem is that it was designed as an interactive experience for a PC, for example. And in VR, it might not be very much fun to play for too long because it wasn't really optimized or designed for that. So going back from scratch sometimes leads to a better experience. This was done by some artists, some media students at the DePaul University in the US in just a couple of days. And it was called Dumpy the Elephant. You have a big trunk. Again, this kind of idea of a new embodiment. You imagine there's a trunk sticking out of your head like an elephant, and you just swing your head back and forth and knock things down. And I don't know about you, but for me that was a lot more fun. Because I can play a first-person shooter game on a regular console or PC, it was great. But this was something I could not do anywhere else. And you can't just sit there with the mouse and move your trunk back and forth. It's just not the same experience. So this was amazing. Of course, people want to try to get as sick as possible, so they may want to do roller coaster rides. Medical applications, you could train doctors, so they can see a procedure that they haven't done yet, or maybe the patient would rather be somewhere else. Socializing, right? Interacting with people, all kinds of interesting things there. There's some interesting research by Professor Jeremy Bailenson at Stanford. Talks about transformed social interaction. There's some things that are possible through avatars that you can't do in the real world. For example, in this lecture today, if we all had virtual reality headsets, including myself, and we're in some virtual auditorium, I could be looking at each and every one of you in the eyes directly, simultaneously, because you could all have your customized versions of reality. So all kinds of weird things. That's great for teachers who want to intimidate students who might be sleeping. Right? I'm looking at you all the time. So you can have perhaps better than usual. And again, through this embodiment idea, you can get people different experiences based on their race, gender, height. You can interact with people as someone else. And that may cause you, again, to go down this path towards empathy, to understand other people's struggles. There's always the problem of the uncanny valley when you try to make things too realistic. Those of you who are game developers know all about that, I'm sure. So, same kind of thing happens here. Do they need to be kind of cute cartoon models, or do we go all the way to try to get a lot of realism until you look like the Talking Dead? Which may be appealing for some folks. It depends on your interest. This was done by artists. I think it was a group of artists in Denmark. They made a virtual guillotine. So you look up and you can see your head about to be cut off. And then if you watch the video on YouTube, they even like whack, their friends would come up and whack them on the neck right when the blade's coming down, just to really scare them. So that's great. That's an experience that's hard to get on just a regular screen or something. So this is what we rely on artists for, right? This is great. I love it. I didn't try it myself, I have to admit. Another Oulu story I'll throw in. The Oulu Library and the University of Oulu have had a very nice project together, again with the Center for Ubiquitous Computing. And in this case, this should be a familiar part of the library here, but it's in the virtual world. And the system was actually developed and set up at the library, so you can put on the headset and visit either the parts of the library that exist, or you can go to magical floors that don't really exist in the real world, so you get like the fantasy library sort of opening up. And perhaps in the fantasy land you can get book recommendations or interesting social interactions, all kinds of things you can do off in the fantasy library world. So that's very interesting. There's a number of people who contribute to that, and Professor Timo Ojala, who's the director of the Center for Ubiquitous Computing, is right here in the front row, so you can chat with him during the break perhaps if he's around long enough. This is probably the best experience I've ever tried. Again, this is by an artist, an art professor at the Zurich University of Arts. You can fly around like a bird. It's called Birdly. And you flap your wings, you can lean and tilt and go swooping around. And I did not even get sick. It's really interesting. Usually I get sick easily, but this one did not do that for me. And there's even a fan here so that as you increase your airspeed, it blows more heavily on you. So it gives you this additional feedback. I found that really powerful. And it's not the kind of thing that people immediately say, ooh, there's a scalable business model. Let's make lots of money with this. This was just a powerful human experience for me, and I really appreciated that. All right, so I talked about VR quite a bit. I'm going to talk about the larger ecosystem and mention AR as well, and then go through art and more things. Hopefully I will not run out of time. So virtual reality, the term goes back to Immanuel Kant, and he was talking in the late 1700s about a kind of internal reality that's in your head or your brain versus an external reality. I'm no philosopher, so if my characterization is too simple, please forgive me if there's any philosophers in the crowd. I'm a doctor of philosophy, but I'm sure that does not mean that I know anything about philosophy. So the term augmented reality came along later, which was to make it so that there's a kind of virtual world that appears that's merged with the real world. And mixed reality is also kind of saying the same thing, but maybe a higher level of graphical fidelity and complexity. Augmented reality was originally maybe just some small amounts of text, like maybe all of your names appear above your heads or something, so that during the break I can remember everybody. I guess we use name tags for that, but it would sure look clever if it just seemed like I remember everybody. Right? So over time, as more and more graphics come into play, mixed reality became a term that tries to unify everything. But it didn't stop there, and I'll say some things about that. I think in modern times it becomes very confusing. Like, this is what some content looks like in some recent Facebook Oculus virtual reality, and this is clearly called VR, and this is what some content looks like for Microsoft HoloLens. Again, you have some kind of very graphical creature here merging with the real world. I think these technologies are really coming back together again, and one of the reasons for that is there's cameras everywhere. So cameras are capturing real world information all over the place, and people are leveraging that. Even in pure computer graphics, there's been texture mapping for decades, taking information from cameras and putting it onto graphical objects. Now it's just really getting ubiquitous, and with the cameras everywhere and in everyone's hands, you see these things merging very naturally. The only thing that's keeping them largely separated today is the display technology, which I will talk about in a bit. I'm promising to talk about a lot of things in a bit. Hopefully I will get to it. Another thing that happens in the AR space is a lot of the interest right now in augmented reality is in what I will call non-wearable AR, which is just holding your smartphone up like a magic window and looking through it. Pokemon Go generated an insane amount of interest by the big companies in augmented reality of this kind. And one of the reasons why is the smartphones are getting to be a commodity now. So sort of almost anyone can make a smartphone in their basement. You know? Well, it's not quite that easy, but it's getting to be like a commodity. And the smartphone makers want to try to differentiate themselves. They want their smartphone to be so hard to make that they have no competitors. And in order to do that, they have to have really interesting content that only works with the hardest technology. And so if this kind of non-wearable AR becomes extremely big and popular, then they can achieve that goal. So different kinds of things in this space. There are makeup apps, kind of a virtual mirror. One can try different forms of makeup. You can take information about the city and augment it. That's Meta.io. That company was acquired by Apple, so it's mysteriously disappeared. But you can get an idea of, just by walking around the streets, you can add information. You can put silly mustaches on yourself or other kinds of things like that. Another example, a company called GeoCV, which I believe was founded in Russia, but now has moved to the US very recently, where you can just take a camera, move it around in say, an apartment, and build a very nice 3D model pretty quickly. And it's very high quality. I've seen some of this work myself, and then you can use that obviously for real estate applications and architecture and things of that nature. To artists, this was something shown by Facebook recently. You know, there's always a graffiti problem, right? Anyone who worries about having their city look nice. I know there's some special graffiti places in Oulu where it's like encouraged, and then there's other places where you probably get arrested or something. So what's nice here is you can just kind of graffiti anywhere you want, and then using this augmented reality technology, you can look through your phone and the environment might look like this, dripping paint, all kinds of things, but in reality it's only through your phone. Right? So this gives you a chance to just go around and be a kind of graffiti artist or do whatever you like around in the real world and have your portraits visible only when the tracking system knows that you're in the right place, looking in the right direction, and it magically appears. Medical training, of course, and especially important use case of the Microsoft HoloLens and things along those directions, which can include Magic Leap and other technologies. This is just one sort of example of that. Also, another thing, if we get all the way to the level of very comfortable wearable glasses that look a lot like the glasses some of you have on today, then maybe it's nice to walk around and have augmented information about the city appearing at times when you would like it, and then you can turn it back off again because you're wearing something comfortable. So you can figure out what restaurant to eat at next, perhaps. This is the kind of vision that a lot of companies have lately. This came out about a year ago, where there's this kind of non-wearable augmented reality. Then it goes to, with just the basic phones that we have, then there's specialized cameras and depth cameras, and then it goes into smart glasses that are perhaps tethered to the phone or a mobile device. and then eventually we want these kind of nice smart glasses. So terminology keeps shifting somehow. I think mixed reality started getting associated a lot with Microsoft's ecosystem. So people thought that wasn't enough, so they made up XR a year or two ago, and now all of these technologies seem to be called XR. I was happy with it VR, going back to a manual count, but fine. So just something to be aware of. One way to unify all of this today is to call it XR. X is presumably like a wild card letter that might cover all the future other realities that might come about. Very quick on history. These concepts have gone back to they could go back a long time depending on how you consider it. I can go back to cave paintings, and I will in a minute, but it's often considered Ivan Sutherland to be the first to produce a virtual reality headset, which today would be called augmented reality because it was a see-through display, just providing some simple line drawings that seem to remain stationary on top of the real world. Then there was this big push in the 80s. The term virtual reality got popularized by Jaron Lanier. University of Illinois introduced this cave system where you had full sort of panoramic viewing and stereopsis as well, so it looked 3D. The big craze in the early wave of consumer virtual reality ended with Nintendo Virtual Boy, which was a disaster. Then there was the next wave with Oculus in 2012, 2016 being consumer VR for the masses. Now I think it's a bit of a downturn from that, but there's a long sort of steady curve of growth nevertheless, but I would say that the peak in some sense of the VR excitement was in 2016. One of the reasons why I was jumping into this technology was I could see that the component technology was not ready yet in the 80s and 90s, and thanks to the smartphone ecosystem it was ready, and things were a lot better, ready to get to some level. But now, the devices or hardware that we have is still not good enough, and it needs to go to the next level beyond that, which I will talk about shortly. Here's some pictures of what I said. So this is Ivan Sutherland's first headset, and you have some kind of contraption over your head here. That's used as part of the tracking system and things. It doesn't look very comfortable. So if you complain about these kind of headsets today, imagine if you tried it in the 1960s. This is a cave system from the University of Illinois. This person here is walking on a treadmill, and you get a kind of nice sort of panoramic view. I think they were doing a study of people's fear in crossing the street when there may be traffic coming. This is how headsets looked before. They look kind of similar, although quite a bit bulkier, but they were significantly worse. It's an older headset from the 90s, some gaming experience from the 90s. This was the bad sort of experience that helped kill the ecosystem before and caused investors to run away anytime they heard about VR, until enough years went by where they don't remember this anymore, and then they jump back in again, some of them. One of the reasons why it wasn't really virtual reality in most people's descriptions, it's a fixed base thing. You just put it on a table, you put your eyes up to it, and then it had stereo viewing, but with red lines on a black background. It was really uncomfortable and difficult, and I think they kind of pushed too hard in calling it VR and oversold it. A lot of popular references and things. You, of course, know about Ready Player One, very recent movie made from Ernie Klein's book. And Lawnmower Man, I've gotten to know Brent Leonard, the director who made Lawnmower Man, and he said something which I'll repeat later, that to make this technology work, you need to have unholy alliances. You really need to bring people together that normally would not be together, or maybe don't even want to talk to each other normally, in order to push these kind of things forward. And that certainly means artists and engineers coming together, which maybe doesn't happen. Well, sometimes it does, but it's hard to really go the full distance. And I'll also argue that perceptual psychologists and neuroscientists need to come together as well into the mix, along with business people and everyone else who may be involved in the end uses. Let me talk a little bit about just art perspective. I'm no artist at all, but I'm trying to speculate wildly about what an artist might find interesting here, so please forgive me if it doesn't hit the mark. Here's some old cave paintings. There's all these tens of thousands of year old paintings. I know there's famous ones in Spain, other parts of the world. This one's in India. So 30,000 year old painting, some level of sophistication there, I guess, looks like what we might call stick figures. And then eventually we get up to something like this, which is certainly much more colorful and detailed, but it's kind of strange in that there's like these really little guys back here. They look bigger, they look smaller than these, and I don't know, it just doesn't look right there, right? What is this missing? They did not seem to understand perspective projection in the Middle Ages at some point, and then all of a sudden they started applying that sort of bit of math or science, and then they have a view like this, which has correct perspective projection. So all of a sudden this is a very 3D looking painting, and this one was not, right? And so the degree of realism kept increasing. And I can see this in the VR technology. The degree of realism keeps increasing. But then people go and do something like this, right? And this is what I want to see. I want the artist to do this kind of stuff in VR. I want to see it. I want to see the same type of progression. It's not all about trying to push the boundaries of resolution and frame rates and graphical fidelity and detail. It's about fooling the human mind in some way, right? Into having some kind of perceptual experience. Artists should be good at that. They are historically. So I want to know what the VR version of this is. And I know there's been some efforts of this in VR. I don't have them on slides, but this is just kind of a general direction. Same thing I can say about film. You know, it's hard to believe that this sort of ancient film here that was taken by a horse running across a field in the 1800s, just triggering a bunch of cameras in succession. You put them together. Supposedly it arose over an argument about whether or not a horse ever has all four legs off of the ground, which seems to happen in frame 2. I think it was Leland Stanford's horse. As it progresses, you know, this was a very, what do you want to call it, difficult to watch 3D film for a lot of people, apparently. A train pulls into the station in a French town in 1896, and there were rumors that people were jumping out of their seats in the movie theater, thinking that the train was going to get them. So, wouldn't fool anybody today. The degrees of realism keep getting higher and higher. You know, there's a trip to the moon where, I don't know, maybe the special effects were not too great when you go and look at that, right? But very famous films, made by artists mostly. Then came years of cinematography and a lot of Hollywood development. The degree of realism we expect keeps going up. You can consider the landmark film of Stanley Kubrick's 2001, and maybe Alfonso Cuarón's Gravity is up to the current standard. My teenage boys can't stand watching this movie. It's just too boring and pointless. But this one has the right level of graphical fidelity for them to consider it to be normal, like acceptable. So somehow the standards keep getting higher and higher. But I will say again, what can we do with simplicity, I think? As an artist, I hope that might be appealing to you. So it seems clear to me, and it's clear to my friend Brett Leonard, other people I've talked to, that cinematography needs to be reinvented. It can't be simply adapted. There's a lot of interesting questions here. How to tell a story in a panoramic or virtual world. And if the user can look wherever they want, or if they can move wherever they like in a larger world, how do you manipulate that to tell your story? Maybe they just ignore your story and just go run somewhere and sit in a corner, and they missed your entire story. Maybe they have your experience over and over again and learn more and more each time. I would say someone coming from a gaming background, they say, oh yeah, that's normal, I build a game world, and they go out and do things. That's fine. But if there's a central story that needs to be told, though, what do we do in this case? You can't simply move the camera view from one place to another like you could so easily before. How to cut between scenes. Very difficult. Extensions of film editing, video editing. And again, I have this final question here. Will simplicity or complexity prevail? Maybe there's room for both, but I feel like simplicity does not get enough attention sometimes. Speaking of simplicity, we can do the same thing with cartoons. We start off with very simple line drawings. This became a kind of a pioneering movement in another direction of animations. And maybe people had not thought of that before, but it kind of grew up the same time as film. Starting from flipping pages in a book, and then you realize you can do this in film, and then you can add more detail to it by the time Mickey Mouse comes along. And you know, more recently, well, not too recent, but still after the year 2000, the world started to look very, very complex. But then we should be reminded that simplicity seems to work, right? So maybe that's part of the comedy of this, but ridiculously simple graphics and animation is also fine. And so back to that same point. Same thing for video games. Hard to believe that this was fun for anyone. But original Pong. When I was young, I lost many quarters on this one. I took all the quarters I could find and spent time playing Donkey Kong like crazy. And it left a lot to my imagination, right? Artists want to leave a lot to your imagination. This was a happy time for me. My kids don't understand why, but it was a happy time. For the next sort of generation after that, it was playing Doom and first-person shooter games, which grew very quickly. The level of fidelity in games today, I think I probably need to update that to something from this year. The game's already even more level of detail, but incredible levels of realism. And then people act as if they were surprised that some very simple games came along. You can take Angry Birds, very, very simple, and yet very powerful, and people are playing games that kind of remind me of the complexity of the 1980s again. Right? This one as well. Notch came out and visited us at Oculus. Very nice, great talking with them, and he was nice to our kids, and everything was exciting and talking to him because he wasn't trying to do high performance computing, and he wasn't trying to make really high graphical fidelity. He was almost apologetic as to having unleashed this thing on the world. He's like, I don't know, it was just kind of a project I did on the side, and I wanted to make it fun for children to be able to build things. And so it really took off, but it was not successful because of its graphical fidelity, right? It was successful because it could run almost anywhere, and it had wonderful interaction mechanisms that seemed to empower young people to build and make these great play spaces and socialize and so forth. So again, the simplicity seemed to, I wouldn't say it won out, it defeated everything else, but there's a huge niche here, much larger than a niche probably, but a huge direction here. I just always love this video from the 1980s. Anybody remember this one? I want the virtual world version of that. Somebody please make that. This is so cool. I'm going to step inside of that. Let's see. So one thing I want to say is artists and perception. So I'm getting into the kind of final phase of the talk. And artists are very good at with I think a deep intuition about human perception and understanding how to fool the brain to trick you into having some kind of experience. So virtual reality technology, XR technology fits very well with that. And I think, if you don't mind me generalizing too much, I'm an engineer kind of first and foremost, and maybe I know a little business secondary, but I think that engineers and business people tend to think that more is always better on these kind of platforms, especially in engineering. Get the performance specs higher, put bigger computers inside, get higher bandwidth, just keep doing more and more and more of everything. By the time you're done in this space, you end up with some big clunky thing on your head that the battery drains right away, and it's difficult to have a good experience on. And it may be the case that there were wonderful experiences that artists could have made on something much simpler. And then if that happens, well, that whole part of the technology will open up. There will be a lot of maybe devices being made. So I think artists are good at understanding when can we get away with simplicity, how much should be left to the imagination. Right? Sometimes it's maybe better to just read the book, and then a lot is left to your imagination, right? So they develop a lot of tricks to convince people, and maybe how to tell a good story fits in there. It's hard to imagine what the future will bring. I love this picture from 1958 of the family sitting around watching television. That must have been quite an exciting feeling there. It seems to be a virtual reality of some kind for them. I guess watching what's inside of the tiny curved black and white tube. And I would guess that in 50 years they will laugh at whatever it is. I guess that's 60 years ago. I guess in 60 years they will laugh at whatever technology we're using today. Right? So it'll be interesting to see how all this evolves, but I'd say it's very hard to imagine. Challenges for these kind of products. I'm going to zip a little bit fast through this to make sure I have time to cover the main points. But there's a lot of struggle right now and a lot of concerns, mainly because of the content and secondly because of the comfort. Moving everything wireless is very important. And figuring out how to distribute computation from maybe your face to something in your pocket, to something in a local base station, to maybe edge computing, to all the way cloud computing. How to distribute computation across these pieces is a fundamental challenge, and next generation display technology being one of the keys, which I want to spend some time talking about here. I like to say there's 3 E's for the product here: engineering, ergonomics, and ecosystem. Ecosystems often neglected, right? People build something and hope that everyone comes and uses it, and that's very difficult. So the engineering part, we have a lot of people working on it, but the ergonomics sometimes gets left behind. It's still very challenging, and the ecosystem being the very difficult part. XR is extremely broad, so the more we slice up the ecosystem into particular use cases and design whole technologies around that, I think the better things we'll do. So you could call it targeted verticals in business language. There's a lot of success in that. One problem that happens over and over again, I call it recycling. People like to use the devices and software and other things that they already have lying around and just adapt them quickly. Like if you have a first-person shooter game, put it into VR and hope it's good. Adapt it a little bit. Well, it doesn't work. It does not work so well. These are very different kinds of experiences, a very different kind of technology. So a lot of things that have been already around, this pertains at all levels: hardware, displays, as I said, software, content. Sometimes you need to step back a lot and go in a completely new direction. So I want to talk a bit about perception, human perception. One thing that was really powerful to me, I gave a keynote once at a VR conference, and when I arrived there, only then did I realize they were not talking about VR applied to humans, they were talking about VR applied to animals. And so they had these mice wearing little miniature headsets. No, I'm just kidding. They didn't have that. This is more like a cave experience where they have a panoramic view, and they go running on a ball, and scientists can study the with single unit recordings. Neuroscientists can study how they build spatial maps. I even saw something as crazy as a fruit fly, a Drosophila, running on a 4mm ball with an electrode coming out. So this is a Nobel Prize winning lab that was in Munich that I saw this in this thing firsthand. So that caused me to really think, wait a minute, we are the laboratory rats when we in this process. So it's very important to understand the human physiology and perception. How many photoreceptors do we have? How do they respond? What are their different characteristics? How does adaptation occur? And if you're a developer in the space, or an engineer, or an artist, you have to be careful, because sometimes you're being like the scientist and sometimes you're being like the rat. And you might change back and forth every time you're putting the headset on and taking it off. So this is very difficult for people to understand. So an artist made this. There's a lot of depth information there. If you go make an experience in VR, you have to understand the technology very well to understand what kind of cues need to be put in there to affect your perception of depth, scale, color, immersion, presence being there, interactivity, all these kind of things. An artist should understand about this technology, what they can get away with. And an engineer should hopefully help educate them on that, and maybe even the artist has a chance to shape the engineer. Because the engineers have, I would say, quite limited imagination relative to the artist. It probably should be that way. And there's a lot of weird things that happen, right? People who study human vision science, when they go to their conferences, they get very excited when someone presents a new optical illusion. So that's a perfectly straight grid, right? We can go up there and I don't know if I have something where I can kind of, these really are straight lines here. See, no tricks. I don't know, but they look curved. Does this look like it's moving to anyone? People in the front row probably. If you're further away, maybe not. So if you look directly at a spot, you can tell it's not moving. But in the periphery all the time, you have this disturbing feeling that the thing is kind of squirming, like a bunch of snakes or something. Very, very strange. So there's all kinds of strange artifacts happening like this in the development of VR technology. And there's going to be many, many surprises as we go down this road. So the thing that was happening back when I was at Oculus in the early times, the scientist and the lab subject were getting mixed together, as I said. We go back and forth between these. And one of the things that I got into was something I call perceptual training. And that may be very helpful for artists as well, and it's very helpful for engineers, I know, which is to train the people who are doing the developing to spot particular kinds of flaws, right? I don't know how it works when you study as an artist. Perhaps if you study painting, they tell you that you understand a lot about the technique. And here's some kind of good artist, and here's some bad artist, and here's why this is better than that. You have perceptual training to understand how to do things, and how to evaluate when something's being done correctly. So when I started working at Oculus, I could not detect latency. That's the delay in the system. When you turn your head and then the image catches up later. I could not detect latency any lower than 40 milliseconds. When I was done, I could detect it down to 2 milliseconds. And I trained myself to just move my head like this with a very low amplitude and about 2 hertz oscillation. And I could notice little tiny shifts in the phase of the objects that are supposed to remain stationary. And then I trained other people to do that. And so, generally speaking, you can train people to look for these kinds of flaws. There's other things you can do. Like, for example, very often there's a mismatch in stereo. The left eye and right eye are not getting consistent images. In the real world, that really doesn't happen. But in VR, it happens a lot. There may be some kind of mistake. And so you just learn to close one eye and then close the other eye and just look back and forth and compare the two. People don't normally do this, so you should train people. So that's one thing you can do. You can train people at least to be a little more scientific, even if they are still sometimes the lab rat. As VR headsets have come along, again, engineering-wise, everything's getting better. The bad stuff is getting less, and the good stuff is getting more. Higher field of view, higher resolution, that's all fine. You may see industry leaders say things like, our headset is so good that it has beaten the sickness problem. And what I say to them is, your headset is so good that it can make people more sick than ever before. So it's something to pay attention to here in this space. Why? Here's an example. So if you're sitting in a chair and you move your virtual self along, which is a common operation, and there's ways to avoid this, that's fine, there's a lot of progress on that. Your vestibular organ that measures your body acceleration is not happy with the visual stimulation of motion. So this is called optical flow. If I start walking forward like this very quickly, there's a kind of optical flow, especially in the periphery, of a kind of separation of features. And so the vision part of your body is telling your brain you're moving, but the vestibular part says, I don't think so. And then when you put these two together, it tends to generate discomfort and nausea in a lot of people. If you've ever been perhaps at the train station, you kind of have another train outside of the window, you're both stopped and then the train starts moving. Did you ever feel like you're going backwards for a little bit? That's what this is doing over and over again in VR. Every time you grab a controller and move your virtual self, and usually in the train you recognize it after a second or two and kind of freak out and then it's okay. And here you have to do it over and over. So the better the headset, the worse it gets. There are many other issues. Just perceiving something in virtual reality or augmented reality, mixed reality as being stationary. So when I turn my head around, it stays in one place. Very hard to achieve that with all of the artifacts of technology that I've not really covered here in detail, but this makes it very, very challenging to achieve. Due to latencies, due to the fact that images on the screen get put out line by line. And so it becomes very, very challenging. And it's a kind of inverse to perceptual science. So perceptual scientists and psychologists study perception of motion. But perception of non-motion or perception of stationarity is the engineering challenge. To make something that's not supposed to be moving really look like it's not moving and in this kind of virtual world that you built. How much resolution is enough? It's known if you talk to optometrists that 60 pixels per degree, angular degree, should be enough so that you don't see the screen anymore. We're still not there yet. We're still off by a factor of maybe 3 or 4, something like that for the types of headsets that are out there. So you can see pixels. Is that a problem? Probably in many cases it is. Another problem is, well, we want higher field of view. If you just put a smartphone screen in front of your face with some lenses, then you're not going to be able to see all the way out here. The human field of view, even when you don't rotate your eyes, I think I can, it's greater than 180 degrees. So I can't possibly put a screen in front of my face and see anything over here. So the kind of devices you have today is still very, very, very limiting. And then this is one of the biggest problems, which is well known in film or movies, just going to the movie theater. If you watch a 3D movie, there's this thing called vergence accommodation mismatch. When you bring your eyes together to look at something close up, your eyes try to refocus on the object that's very close. Because it has to change the diopter of your eyes to look at something that's close up. But in virtual reality systems, most of them that are around today, almost all, and in movie theaters, it's already in focus all the time. Each eye gets something that's perceived to be very far away by the eye physically. And so there's no need to refocus. So that changes this very tight coupling that happened that's part of the human body between the eye focus muscle and the eye converging muscle. And you're trained to decouple these by these systems when you put something very close. That's why in the movie theater, most of the 3D content is far away now. Because too many people got headaches and had problems from it being too close. So this is a very big challenge. There are steps to address that, but right now I would say we're in a kind of display plateau. That next generation display technology is very, very important. Which, by the way, there's a lot of progress on that inside of Finland. Finland's a world-leading place on next-generation display technology. It may not be known by everybody, certainly not known by everybody outside in the world, but people close to technology here know that there's very significant research that's been done and technology has been developed, some Nokia, some in universities, some in small companies. Just as an example, is a great headset by Vario, which provides this actual 60 pixels per degree, but only in a small area in the front, and then the rest is a more standard display. So that, for the first time in VR, you can actually look and read things. Foveated rendering, a lot of people are working on that, especially NVIDIA, so that you can at least get very high graphical quality here, and then you can make it sort of lower quality in places where your photoreceptors are at less density. So maybe this will work out pretty well so that you don't have to generate all these graphics in a virtual setting. So that's another problem. There's waveguides, which are the basis of augmented reality technologies such as Microsoft Hololens, Magic Leap 1 as well. And the biggest limitation there is a narrow field of view. So these things work by having some light source projector, and then the light bounces around through these waveguides, and then out it pops in your eyeball. In different places you can rotate your eyes and you still see the image, but getting beyond some small field of view is very tough. This is examples of the HoloLens and Magic Leap field of views. HoloLens is already kind of old. There's probably a new version of this coming out soon, so I hear, I don't know. But very narrow field of view. Magic Leap, with its $1 billion investment, is a little better. So I would call it, instead of magic leap, maybe significant step. That's the part you edit from the video. Let's see. So retinal projection technology, I find very promising. I don't know if anyone's heard of this, but you can shine a laser directly onto your eyeballs. Has anyone tried that? No, you probably should not do that. If you want to do it, here's the kind of laser you need. You need to have a laser that's very, very small beam, so that it draws kind of a pixel onto your retina, let's say, something that's very, very small. And the laser needs to have a very nice, let's say, low power linear operating region. Most of the time when you increase the voltage across a laser, it goes from no light to bam, a whole bunch of light. And everyone's fine with that, right? Because you want to use your laser to, I don't know, to point or to cut a table in half, well, whatever it is you want to do. And so, but if you find a laser that has this very nice operating region that goes from 0 to slightly better than 0, and is very nicely controllable, then you can start drawing on your eyes. And there's also MEMS technology, MEMS mirrors, that are starting to get very fast, so that you can turn your eyeball into like a CRT monitor, and you just start drawing patterns on your eye. I've tried this kind of technology, and it's quite impressive. One of the best lasers around right now in the world is from a Brighter Wave down in Tampere. So sorry, Tampere is winning in the laser world. Maybe Oulu will have to get caught up in laser technology. In terms of increasing field of view, Oculus Half Dome has been substantially increasing that in one of their prototypes. This will continue to improve, but again, there's this limitation going all the way to the periphery with this kind of idea of putting lenses in front of a single screen. So some final remarks here. The concept that I've been pushing, been very interested in, I call it perception engineering. And this hopefully should be appealing to artists, but I mainly mean it as a sense of bringing perceptual science into an engineering kind of context, where there are very clear criteria, ways to evaluate things, ways to make systematic progress. So we use this technology to design, develop, and deliver perceptual experiences. This may be a term that you could just call it all of XR, it doesn't matter to me, but this is how I think of what we're doing. So you are engineering a perceptual experience. And I would say that an artist is designing a perceptual experience as well, in many or most of the work that they do. And by this I mean human perception, not machine perception. But this is a very kind of natural thing to me. I got this idea for this term. I was working at Huawei as a vice president a couple of years ago, and before I joined, I met an engineer who was working on a VR project, and he said he had 100 engineers working on this, but he did not have a single perception engineer who kind of really understood what was going on with the way the devices interact with the human body to understand how the perception works of what they're engineering. It's a completely new thing for them. So I see this kind of thing happening. There's these sciences that get warped into becoming fields of engineering over time, civil engineering being the oldest, like basic sanitation, for example, and then it goes on and on to electrical engineering. And I see perception and neuroscience morphing its way or working its way into perception engineering, taking this kind of science and adapting it into an engineering context. And then we have the usual engineering, which has all this XR software and hardware, and then we have a process of reverse engineering, because we did not design ourselves. So we have to rely on neuroscientists and psychologists and other people in that space, physiologists, to reverse engineer this system and then understand how these fit together very tightly through the interface of the human senses. And I think artists have already been manipulating perceptions for a long time, as I've said. So this should fit very nicely with that. I just want to take these scientific and engineering disciplines and try to bring them close together as well. And if artists can become involved in that, all the better. So there's many perceptual issues in panoramas, for example. I'm going to skip ahead a bit because I think I'm running out of time. But there are basic perceptual issues in panoramas, like perceiving depth and distance, which need to be studied. Both artists and engineers and device makers, everyone needs to learn these kinds of things. This is a very simple example of a criterion. We want to understand, if we develop something, what the criteria need to be. This relates to a very big field called visual quality metrics, which have been used for images and videos. And in VR, it's much more complicated. Maybe forget the plots for a minute, but there's two cases. Suppose you want to move yourself along in VR using a controller, as I described. Should you instantaneously move yourself, or should you gradually go faster and then move? It turns out the gradually case seems to be much more sickening than the instantaneous case, which is counterintuitive. And so that's just one example where you need a criterion that measures which way is better, and have that backed by science that's been done with human subjects, and you've evaluated this very carefully, and then you try to move forward to make sure that you're developing a system that does not make people sick. It's very hard for developers to do that, especially in, say, a small game studio. It'd be very hard for them to have time to do these kind of evaluations. But overall, as scientists, researchers, and people maybe in larger industry endeavors, there should be more work on this to try to understand what these perceptual criteria are and need to be, and then make sure that we're making progress towards that. I did not mention interaction at all, but what can we do with, let's say, some new embodiment, right? We imagine we're something else. How do we interact with the world? Maybe I'm a bird flying around. Maybe I've changed my gender. Maybe I've done something else. I don't know, but how do we interact then? Still a very big, fascinating question. And I did not even, everything I was talking about was video related. There's audio and touch and taste and smell. And even vestibular stimulation, which I do not recommend. I've tried that before. Don't ever let anybody trick you into that. And all kinds of other interaction here. So it's a huge sort of area that I see as this human perception engineering research. Here at the University of Oulu, I came here very excited to join a couple of months ago, starting this new center, co-founding it with Professor Timo Ojala. And this is part of the Center for Ubiquitous Computing, and also connects to this big flagship 6th Genesis next generation wireless. They're already bored with 5G here, so they're on to the next one. So that's very exciting, and that's important in this space with wireless devices. As I said, everything is moving wireless in this space. And so unholy alliances across Finland would be something I would love to help put together, try to bring people together to push on these things like the perceptual criteria, to try to understand and work together to try to make sure we're providing better human experiences and the kind of things that we want, and aren't hopefully stifling people's creativity. And I love robotics still, so I have to mention that. I'm not gonna, there's a lot of interesting possibilities. I have a free book, so you're welcome to go and download that. Should be published by Cambridge Press one of these days. But that mixes this human perception perspective with the hardware and software engineering. If you just Google for my name and VR book, you should find that also. And again, as I said, in the early days of Oculus, there was an Oculus office in Southern California, and there was an Oculus office in Oulu. Does anybody know that? Yeah, so it was in our apartment in Panoramas. And that's my wife, Anna Yashoma, who's also Anna Lavalle, who's also at the works as a lecturer at the university here, and working together on these things. And there's a picture of us with a robot. That's the original Oculus sensor. Something mysterious here. If you take Oculus and you get rid of CS, it becomes Oulu. You can decide what the C and S are. I don't know what's being removed there, but it was a very, very nice, fun connection. I was here on a sabbatical back then, and I did the first 6 months of work for Oculus. The only Oculus Rift prototype to leave California I had for a while in my apartment here secretly. We worked on the early head tracking, 3-DOF and 6-DOF tracking systems, and then I eventually left and moved to California. But at the time we started, there was not even an Oculus office yet. It was just right after the Kickstarter. And this final slide here, the entire Oculus story, if you're interested in reading something that maybe is kind of like the Social Network movie or something like that, if you want to figure out all the characters involved and what kind of things happened, this is, I think, will be a really interesting book. I know the author very well. I've read some parts of it myself and helping him, and I think it'll be fascinating. I'm a minor character in there, and my nickname is the Enigma. Like, what is this guy doing here, and why did this guy leave again? Who knows? So I'm a strange character. All right, thank you very much.